Hi, welcome to this video. In this video, I am going to discuss how to find integrals of functions by using method of partial fraction. First question which comes to the mind of students is, when do we use partial fraction? And answer of this question is, whenever the given integral is in the form of px upon qx, where qx is not equal to 0, and the denominator can be factorized into two or more factors, provided none of the factor has degree more than 2. That is, we cannot have any factor whose degree is greater than a quadratic polynomial. It means whenever we have a rational expression px upon qx and denominator, that is qx, can be factorized into two or more factors, plus none of the factors of denominator has degree more than 2. It means the highest factor of the denominator can be quadratic polynomial. We cannot have a factor which has a degree more than a quadratic polynomial, that is degree more than 2. There is one more condition. Before we use partial fraction, we have to ensure that the fraction which is given to us is a proper fraction. Now, what is the meaning of proper fraction? Proper fraction means the degree of denominator has to be greater than degree of numerator. And what if the fraction is not a proper fraction? That is, we call it an improper fraction. If degree of denominator is equals to or less than the degree of numerator, we call it an improper fraction. So in case we have an improper fraction, we must convert it into a proper fraction. And question is, how do we convert an improper fraction into proper fraction? Let us take an example. For example, x squared plus 1 upon x squared minus 5x plus 6. In this case, degree of numerator is equal to degree of denominator. Now, what will we do? We will divide the numerator by denominator by long division, which I have shown in this slide. So, by dividing, our quotient is 1, remainder is 5x minus 5. And the fraction, given fraction will become quotient plus remainder upon divisor. That is 1 plus 5x minus 5 upon x squared minus 5x plus 6. And after applying this step, we will get a given fraction in the form of tx plus p1x upon qx. Tx can directly be integrated. P1x upon qx is now a proper fraction. So students, in which all cases do we use partial fraction? First of all, the expression has to be in the form of px upon qx. And qx can be factorized into two or more factors where none of the factor has degree greater than 2. And last but not the least, the fraction has to be proper fraction. And in case if it is not a proper fraction, what are you going to do? Yes, you will convert the given improper fraction into a proper fraction. The next question which generally comes to our mind is, why do we use method of partial fraction? And the answer is that yes, we can solve most of these problems wherever it is linear upon quadratic or constant upon quadratic. We can use the formulas which I discussed in my previous video, that is those particular forms, completing the square method, we can solve it. But still, few problems wherever denominator can be factorized, students, we generally prefer this method because students generally feel that it is more convenient. Otherwise, there is no hard and fast rule. We can solve the same problems using the previous method also, that is completing the square and using particular form. At the same time, in case if denominator is a quadratic polynomial or a higher polynomial with degree more than 2, and it can be factorized into two or more factors where none of the factor is higher than a quadratic polynomial, we use this method, and in such cases the previous method cannot be used. Last but not the least, how do we use method of partial fraction. I will explain the method of partial fraction step by step. Let's see the step number 1. Step number 1 is factorize the denominator. After obtaining a given fraction into a proper fraction, so means first I'll convert the given fraction into partial fraction and then I convert the denominator, I'll factorize the denominator. For example, we have integral of x squared plus 1 upon x squared minus 5x plus 6. Numerator and denominator degree is same, means it's an improper fraction. After dividing, we'll get 1 plus 5x minus 5 upon x squared minus 5x plus 6 dx, which I have just discussed in my previous slide. Now, factorizing the denominator of the fraction will become x minus 2 and x minus 3. As far as 1 is concerned, the integral is very simple. We will get x as integral. Now, we will discuss how to find integral of the given fraction, which is 5x minus 5 upon x minus 2 times x minus 3. Step number 2 is convert the given fraction into partial fraction after identifying the form from the given table. So students, if the given improper fraction is converted into proper fraction, we will get one out of these 5 forms. Depending upon the form which we will obtain, we will convert the given fraction into a partial fraction. So how will we convert the first one? First one is px plus q, that is linear upon linear into another linear polynomial. So in such cases, we will write the fraction as a upon x minus a plus b upon x minus b. Second case, after factorizing the denominator, suppose denominator is a complete square. For example, x minus 2 whole square. If denominator is x square plus 4x plus 2, it's x plus 2 whole square. In such cases, the partial fraction will become a upon x minus a plus b upon x minus a whole square. Now, students, very important to note here is, if you observe, it is a upon x minus a and it's b upon x minus a square. Now question is, why we have to write x minus a square? Why can't we do with x minus a? To answer this question is, what if we take LCM of these partial fractions? Suppose we take a upon x minus a plus b upon x minus a and we do not take the square in second fraction. What if we take LCM? We add these two partial fractions and take LCM. Students, the LCM will be x minus a and the numerator will be a plus b. It means I will get fraction which will be constant upon linear, whereas our original fraction was linear upon quadratic. Hence, we cannot take x minus a as denominator of the second partial fraction. That's why x minus a whole square has to be taken. Now the next question which comes to the mind of students is, why can't we take x minus a whole square in both the partial fraction? Again, answer is, suppose we take x minus a whole square as denominator of both the partial fraction. What if we add these two partial fractions? The denominator will become quadratic, but the numerator will still be a constant. It means it will not match with the original expression, original fraction which is given to us. That's why we will write the partial fraction as a upon x minus a plus b upon x minus a square. Square will come in the denominator of the second partial fraction. Similarly, third, fourth and fifth forms of fractions can be converted into these partial fractions. The first one, a upon x minus a plus b upon x minus b plus c upon x minus c. Next one, a upon x minus a plus b upon x minus a whole square plus c upon x minus b. As I discussed in the second fraction, second form of fraction, exactly similar. Last but not the least, students, in last case, remember x square plus bx plus c is a factor which cannot be further factorized. And this fraction, in order to convert it into partial fraction, I must write it as a upon x minus a plus bx plus c upon x squared plus bx plus c where x square plus bx plus c can't be further factorized. Very important. Step number 2, that is, convert the given fraction into partial fraction as per the form mentioned in the previous table, which I have just explained. So convert the given fraction into partial fraction. For example, x minus 1 upon x square minus 5x plus 6. If we factorize the denominator will be x minus 3 times x plus 2. And the partial fraction, it is, if you compare it with the table which I discussed, it is the first form. Hence, the fraction has to be written as a upon x minus 3 plus b upon x minus 2. So, after converting a given fraction into a partial fraction, we will have few unknown constants, a, b, and maybe we may have c, d also. Now, our next step will be to find the values of those unknown constants. How do we find the value of these unknown constants? Let us take the previous example only, where denominator was x minus 3 times x plus 2 and the partial fraction is obtained on the right hand side. Now what I am going to do is, I will take LCM on the RHS. LCM will be x minus 3 times x plus 2, which can be cancelled on both sides, and I will be left with x minus 1 equals to a times x plus 2 plus b times x minus 3. Now how to find values of a and b? If I substitute x is equals to 3, what will happen? The second term on the right hand side will vanish. It will become 0. The term only unknown constant which will be left will be a, and I can easily find a by substituting x equal to 3. So I'll use this method of elimination, put x equal to 3 on both sides and get the value of a, which is 2 by 5. Similarly, if I put x equals to minus 2, the first term on the right hand side will vanish and I can easily obtain the value of b. So after substituting x equals to minus 2 both sides, I'll get minus b equals to minus 5 times b, and b equals to 3 upon 5. So after converting the given fraction into partial fraction, the integral will become 2 upon 5 times integral of 1 upon x minus 3 plus 3 upon 5 times integral of 1 upon x plus 2, and the integral will be 2 upon 5 times logarithm of x minus 3 plus 3 upon 5 times logarithm of x plus 2 plus a constant. My suggestion to the students is, in case they are doing calculus, they should do lot of written practice. By end of the integral calculus, there are so many types which the students they do during the chapter, and all those types get mixed up in the mind, and in exam when they see the question they are unable to answer. So written practice is very, very important. Moreover, it is well said that mathematics goes into our mind through our hand. Thank you.